Good morning, Doctor. I'm Ng Xin Yuan. This is our group video presentation for the CST235 group project. We are from Group 11. Our goal selected scenario is ShopEase, a rapidly growing e-commerce company that provides online shopping service through both web and mobile application. ShopEase serves thousands of customers every day and handles online transaction, order management, and delivery tracking. The main user of the system include customer, administrator, warehouse staff, and customer service representative. Its network infrastructure consists of web and database server, a payment gateway, governance LAN and Wi-Fi networks, and an internet connections. Important information access include customer data, payment informations, inventory records, and order transaction. Therefore, ShopEase face security threats such as data breach, malware, phishing attack, distributed denial of service attacks, and unauthorized access, making strong network and security measures essential.
Moving on to our foundational infrastructure, the ShopEase network relies on a highly structural three-type hierarchical network designed to guarantee the enterprise-graded security, deterministic traffic path, and seamless transaction scalability. Starting at the edges with our access layer, we deploy a cost-effective star topology to connect physical endpoints for our administrator, warehouse staff, and customer service representative. To eliminate the risk of wireless sniffing or unauthorized access to our inventory system, we utilize a centralized wireless LAN controller enforcing WPA3 enterprise encryption, ensuring our internal staff networks are completely segregated from public and guest users. This endpoint aggregate out at our distribution layer, where layer 3 routing switch act as our strict policy enforcement point. This is where we configure our internal VLAN access control list. If an endpoint in the access layer accidentally compromises the network via phishing or malware link, our distribution layer ACLS instantly block the VLANs, keep the threat from moving on laterally into our core production environment. Finally, our core layer serves as an ultra-high-speed backend backbone. Here, redundant layer 3 switch provide continuous availability for our central infrastructure, including our DNS, DHCP, and our web server. Crucially, our production database server, which contain our highest value digital assets like customer credential and payment info, is isolated deeply within this core zone and heavily guarded by a perimeter next generation firewall, configured to mitigate the DDoS attack and prevent unauthorized data exfiltration. By mapping our entire system into these three-type framework, we create a resilient and defensible structure that blends networking efficiency with robust security mechanism.
Good day everyone, my name is Sanchi. I will present our e-commerce enterprise network diagrams part. The network is divided into 3 layers as Kerry mentioned before. The access layer connects end users' devices and wireless access points from different business departments. The distribution layers consist of multi-layer switches responsible for inter-VLAN routing, traffic aggregations, policy enforcement, and access control. The core layer serves as the high-speed backbone, connecting the server infrastructure, internet edge, and VPN connectivity to the main branch networks while ensuring low latency data transmissions across the enterprise. This diagram illustrates the layer 2 access layer topologies for the customer service and logistics departments, where all end users' workstations are connected wirelessly via a WAP. The primary servers contains the e-commerce web server, media and product image server, order processing and API server, customer and catalog database server, DNS server, and DHCP server. To support business continuity, a secondary backup server room replicates these services and can take over during hardware failures or maintenance activities. These designs ensures high availability, data accessibility, and secure external communication. All end users access switches across departments, including corporate administrations and HR, finance, procurement, customer service, and logistics, are connected to multiple distribution layer switches using redundant uplinks. The distribution layers performs inter-VLAN routings and traffic filtering while distributing networks traffic efficiently towards the core. If an uplink or switch fails, protocols such as spanning tree protocols and link redundancy mechanisms allow traffic to be automatically redirected, minimizing downtime and maintaining network availability. The network is segmented using VLANs and subnetting. For examples, corporate administrations and HR departments is logically segmented using VLANs. VLANs 11 for HR staff, while VLANs 12 for general staff. VLAN 11 is assigned to 10 HR staff computers. IP address range is assigned. All HR devices connect to the administrative staff switch through RJ45 ports. VLANs 100s and 200s is wireless access point. VLAN 100s for internal staff wireless access, while VLAN 200s for guest wireless access. Overall, these architectures provide secure segmentations, efficient traffic management for supporting e-commerce operations and future business growth.
During security review, several critical vulnerabilities in our initial core layer design are identified. Our e-commerce server and payment gateway were mixed with internal server, and our database was sitting without proper encryption. This was a massive risk for a data breach. To fix this, the edge network is re-architecture. We created a dedicated DMZ architecture to physically and logically isolate the web server and payment gateway. At the perimeter, our next-generation firewall with thick packet inspection integrates DDoS and malware. For zero trust protection, all sensitive database now strictly enforce AES 256 encryption at rest. At the distribution layer, our focus shifts to internal threats. If one single point is affected, it must not spread across the entire company network. We solve this through literal containment. We configure hardware-based access control lists on our multi-layer switches to strictly prevent pirating between departments. An IDS-IPS system actively monitors all inter-VLAN traffic, catching and isolating any internal threats detection immediately. Finally, at the access layer, we apply a risk-based approach. We heavily target the administration, finance, and customer service department because they hold the system privilege and payment data. For those high-risk departments, we implemented strong authentication using 802.1x for wireboards and WPA3 Enterprise for wireless network. To combat phishing, multi-factor authentication is strictly enforced for all admin and financial access. Furthermore, a strict role-based access control maps users to distinct VLANs, limiting their access to only what they need. Together, these controls form a comprehensive physical and logical security framework.
This table summarizes how our different in-step strategy protects ShopEase against different security threats. First, DDoS and malware attacks are mitigated at the edge router and DMZ using the next-generation firewalls with traffic filtering and DMZ isolations. Second, the risk of data breach is reduced by isolating the customer and catalog database and protecting sensitive data information using AES 256 encryptions. Third, to prevent internal malware and lateral movement, hardware-based ACLS and IDS-IPS monitoring are deployed at the distribution layer to control and inspect inter-VLAN traffic. Next, phishing attacks are addressed through multi-factor authentications and role-based access control for users in VLAN 11, particularly administrative and executive staff. Finally, unauthorized access is prevented through WPA3 Enterprise and 802.1x authentication at the access layer, securing both wired and wireless connection in VLAN 100 and VLAN 200. Overall, this layer approach ensures that each threat is countered by the appropriate security mechanism at the right point in the network, strengthening the confidential, integrity, and availability of ShopEase critical access.
This is the threat and risk analysis for ShopEase. To design a truly secure infrastructure, we systematically evaluated our threats by mapping them directly to our targeted assets, figuring out their specific technical weaknesses, and weighing their likelihood against their business impact using an industry-standard qualitative scale. If we look at our highest exposure vectors, phishing holds a high likelihood because it exploits the human element specifically, targeting our public-facing customer representatives and administrators. A successful exploit allows attackers to steal credentials and move laterally inside our network using the compromised staff accounts. This leads directly to our most severe threat, which is the back-end data breach via SQL injection on our database server. Although the likelihood is medium because it requires an active coding error, but the business impact is catastrophic. As security professionals, we hold a strict ethical responsibility to protect user privacy. Failing to secure our database results in the theft of customer payment data, massive financial penalties under data protection laws such as Personal Data Protection Act, and the permanent destruction of company trust. On the operational side, we analyze malware and ransomware attacks targeting our internal company local network. Because we currently have a flat network topology with no segmentation, a single infected endpoint could lock the entire system, resulting in a major impact that completely frees our warehouse operations and inventory needs. Lastly, we evaluated distributed denial of service attacks targeting our external web servers. This represents a moderate business impact where flooded internet connections cause temporary website downtime and immediate live sales revenue loss during high-traffic shopping events.
To mitigate this critical issue, we have proposed several defense such as web application firewalls and data encryption for data breach problem, mandatory multi-factor authentication, role-based access and security awareness training for phishing issues, endpoint detection and response mechanism and network segmentation to solve the malware attacks, and network load balancing to reduce the probability of malware attacks.
Hello everyone, my name is Yo Zhong Xiang, and I'll be walking you through the specific security technologies we have implemented for the ShopEase e-commerce network. As you can see from the diagram on the left, we didn't just rely on a flat network or a single perimeter firewall. Instead, we design a comprehensive defense-in-depth architecture with multiple security layers to protect our organizational assets. Starting at the utmost layer, the perimeter edge, our first line of defense includes a next-generation firewall and a web application firewall. Since Shopee processes thousands of daily transactions, these firewalls actively perform deep packet inspection to block external web exploits like SQL injections. Alongside this, we utilize a content delivery network to absorb volumetric DDoS attacks, ensuring the storefront remains fully available during peak traffic. Moving into the internal network, we focus heavily on identity and access management. To neutralize phishing and credential theft, multi-factor authentication is mandatory for all administrator accounts. We also enforce strict role-based access control. By using WPA3 Enterprise, we ensure that warehouse staff and customer service representatives are restricted entirely to their specific VLANs, strictly enforcing the principle of least privilege. To defend against malware spreading internally, we utilize hardware ACL, IDS, and IPS to monitor inter-VLAN traffic at the distribution layer, enforcing lateral containment. Additionally, endpoint detection and response is deployed across all company LAN devices. Finally, at the core, we protect the most critical data. All sensitive customer and payment records in our isolated database server are secured with AES-256 encryption at rest. Furthermore, to prevent any eavesdropping, data moving between our DMZ and backend servers travels completely within a secure TLS 1.3 cryptographic tunnel.
This layer approach guarantees our infrastructure resilience. While this technology provides the technical control needed to secure the network, the selection was not arbitrary. In the next slide, we will justify why this specific technology was chosen and how they support Shopee's operational and security requirements.
I am Tan Jing Eun. Now that we have seen where these controls are deployed, I'll justify why we select them. Every technology on this slide was chosen to address specific vulnerabilities in Shopee's business operations. Let's start with perimeter and web protection. Standard firewalls miss application layer attacks like SQL injections, which target Shopee's public storefront. We implemented an NGFW and WAF for layer traffic inspection, blocking attackers from exploiting web vulnerabilities to reach back-end inventory systems. Additionally, Shopee's downtime directly hosts revenue generation. Our CDN utilizes distributed infrastructure to absorb massive DDoS floods, preserving storefront availability during peak demand. Moving to identity and access management, password-only access for Shopee staff is highly vulnerable to phishing and credential theft. We combine independent verification factors through MFA with operational role-based permissions via RBAC. This ensures that warehouse and customer service staff only access what they need, strictly enforcing the principle of least privilege. For cryptography and data protection, customer payment data travels multiple systems during the checkout process. TLS 1.3 deploys stronger cipher suites to ensure communication confidentiality without adding latency to live online transactions. At rest, Shopee's centralized databases remain high-value targets. AES-256 applies efficient cryptography to prevent data exposure and privacy breaches even if physical storage media is compromised. Finally, our internal network defense. Flat networks allow attackers to pivot easily from the web server into the internal corporate LAN, isolating internet-facing services in DMZ and separating departmental traffic via VLANs minimizes lateral attack propagation across the organization. Because segmentation alone cannot spot malicious activity within authorized paths, we pair hardware ACLs with IDS, IPS for continuous behavioral monitoring. Lastly, perimeter defenses cannot detect malware introduced directly via a compromised employee device. EDR executes direct monitoring on all corporate endpoints to isolate malware before it disrupts internal warehouse or building operations. Now I will pass the floor to Lin Pei Xuan to discuss the ethical and professional considerations of our design.
For this section, I'll be discussing the ethical and professional consideration in Shopee's network and security design. Specifically, I will explain how the architecture addresses three key areas: privacy protections, access control, and responsible monitoring. Firstly, let's look at privacy protection. Shopee handles highly sensitive information, including customer data, payment details, and order records. Ethically, we have a responsibility to protect this data even if physically security measures fail. Therefore, all data stored in the database server is encrypted at rest using AES-256 and all traffic between the DMZ and the backend is encrypted using TLS 1.3. In addition, we follow the principle of data minimization, meaning we only collect what is necessary for processing transactions. This not only reduces the impact of a potential breach, but also aligns with PDPA requirements. Secondly, moving on to access control and responsible use. One of the major ethical risks in any organization is the misuse of access privileges. To address this, we apply role-based access control so that the warehouse staff can only access inventory system, while customer service staff can only access all the related systems. This follows the principle of least privilege. Furthermore, for administrators who hold the highest level of access, multi-factor authentication is mandatory. This is not simply a technical safeguard, it is a professional responsibility, since admin accounts are the highest value target for attackers and protecting them ultimately protects every customer's data. Thirdly, we come to responsible monitoring and administration, which is often overlooked but is central to ethical network management. Our IDS and IPS system monitor inter-VLAN traffic for threats. However, this monitoring is scoped, meaning it does not inspect staff personal communication, disrespect employee privacy while still protecting the organization. Equally important, all staff are made aware of this monitoring scope through an acceptable use policy, ensuring transparency and informed consent rather than covert surveillance.
Part of the implementation consideration is to deploy our NGFW on-premise at data center, which comes with 3 key challenges, each paired with a practical solution that we propose. The first challenge is the performance bottleneck, which is caused by SSL inspection. Since most of our e-commerce traffic is encrypted in HTTPS protocol, deep packet inspection can slow things down. Our solution is to deploy an NGFW with hardware acceleration scaled appropriately to handle peak transaction volume. The second challenge is policy misconfiguration risk. Overly strict rules could block legitimate payment traffic, while only loose rules expose vulnerabilities. Our solution is a staged rollout which follows the deployment timeline as shown in this slide here. This timeline spans 5 phases. Phase 1 is planning and procurement. In weeks 1 to 2, we finalize NGFW specifications and procure hardware and licenses. Phase 2 is staging and testing in week 3, where we configure and test the NGFW in a non-production environment mirroring our live network. Phase 3 is the parallel run in week 4. The NGFW runs inline in production but only logs activity while the existing firewall continues handling real traffic. Phase 4 is cut over during off-peak hours in week 5, where we switch the NGFW to active enforcement with minimal disruption. Finally, in Phase 5 is post-deployment monitoring from week 5 and onwards, where we review logs daily to fine-tune our rules. This stage approach let us catch and correct misconfigurations before they cause outages. The third challenge is ongoing maintenance overhead. Our solution is to schedule maintenance during low traffic hours with support from our NGFW vendor for firmware and signature updates. Finally, to ensure staff readiness, we adopt a setup program for security education on phishing and password hygiene, training for IT staff on NGFW rule management, log analysis and IPS tuning, and ongoing awareness through regular phishing drill tests. Together, these measures ensure our NGFW deployment remains secure, well managed, and continuously available.
Good day everyone, I'm Jim Baoshen. To conclude our project, this slide summarizes how our ShopEast e-commerce network design connects the business scenario, network topology, security control, risk mitigation, and ethical operation into one complete architecture. On the left side, the overview shows our security architecture and risk control mapping. The key idea is that ShopEast cannot depend on a single security tool, since the company handles customer accounts, payment data, inventory records, and online transactions. Protection must be applied in layer. First, our third tier infrastructure separates the access, distribution, and core layers. This improves network control, scalability, and availability. Department-based VLAN segmentation also helps isolate different business units, while separate server rooms reduce the impact of the server failure. Second, the perimeter and web protection layer secure the public e-commerce storefront. And GFW, WAF, CDN, and DMZ isolation helps reduce SQL injection, DDoS attacks, and external web exploits before attackers can breach the end order, inventory, and payment system. Third, sensitive data is protected through TLS 1.3 and AS256 encryption. At the same time, MFA and RBAC enforce this privileged access, ensuring staff only access systems required for their rules. Fourth, internal defense is strengthened using VLAN segmentations, ACLS, IDS, IPS, and EDR. These controls reduce lateral movement, detect suspicious activity, and contain endpoint malware. Overall, our purposes design and deliver a secure, resilient, and ethically managed ShopEast infrastructure that protect public services, internal networks, customer data, and business continuity.